We're going to dive into our discussion and comparison of a couple of point-to-point WAN protocols now, HDLC and PPP. And we're going to run a lot of labs in the next couple of sections here. And we've got router 1 on serial 1. We're going to put the IP address 172.12.13.1/24. And on the other end of the point-to-point serial link, we will put 172.12.13.3. I'll also show you or kind of describe to you how you do this in a lab, because they are directly connected at their serial 1 interfaces with what we call a DTE-DCE cable. And if you haven't seen that before in the material, you'll definitely see it now. I'll discuss that as we go along. Now, Cisco, just to be different, not really, has its own HDLC variation. It's known technically as CHDLC, and with a little C in front of it, I just think it looks more like a chemical element than a protocol. I doubt very strongly you see this reference on your Cisco exams. If they mention HDLC, just assume they are talking about Cisco's version of HDLC. But if you're reading any vendor-independent books or videos, either now or in the future, obviously for the CCNA we're not being vendor-independent, but other reference terms or books may refer to it as CHDLC. I want you to know that that is Cisco's version of HDLC. Now, the reason they developed their own was that the original HDLC did not support multi-protocol situations or multi-protocol networks. And that's really not a very good idea. So Cisco came up with their own HDLC a long time ago, or their own type, if you will. And the reason that I mentioned the word type is that that's how they allowed the multi-protocol support. Literally, they added the type field in HDLC to allow that multi-protocol support. A couple of other notes here. Cisco's version of HDLC is not Cisco proprietary. You would think it is, but it isn't. Also, this is the default encapsulation on Cisco router serial interfaces. So if you're looking at a config and you're looking at the serial interface and you don't see the word encapsulation with a protocol after it, you're running HDLC. We'll see that on the live equipment here in just a moment. Let's go ahead and jump on the lab here. We're going to put our IP addresses on, open our interfaces and all that good stuff, and then of course we'll verify it with show interface serial. So let's jump right in. So 212.13.1. I went in and did a write there, and you could have done a copy run start, but what do you think we're going to see? And I guess there's a hint there on the screen. What are we going to see if we do show interface serial right now once this gets done? This is a little unusual because you'll see administratively down, of course, when it's shut. And the one we have to troubleshoot most often is really, the physical interface is fine, but the line protocol is down. But here, we're actually going to see that the interface is down. This is one reason that a serial interface can be down, is that the device it's connected to, which in this case is router 3, is not open yet. So we expect to see down and down right now. It's just because we haven't finished the configuration. Also note right here, encapsulation HDLC. So again, if you look at the config and you don't see an encapsulation named, then you're running the default, and that is Cisco's HDLC. Let's hop over to router 3. And we'll do a quick save there. I just get in the habit of doing that too when I'm going to be going from one router to another. But here, we get line protocol change state to up, so that's good. The interface is up and everything's looking fine. And we'll just do a show interface serial 1 to verify that. Everything looks fine. And then on router 1. And, we seem to have had a problem just pop up. Serial 1 is up, line protocol is down. Let's go back to router 3. And double check that, and you can see the exact same thing. Whether you're troubleshooting or whether you're configuring something for the first time, I beg of you, and when you see a line protocol come up, stick around for a minute or so and make sure it stays up. Because you could have a couple of different kind of mismatched things that we're going to be looking at, all of them in this section. You could also just be missing a value that you need. But what happens is sometimes the problem manifests itself immediately. And sometimes, as we just saw, it didn't, because it would have been really easy to say, okay, we opened that third router 3 interface and we walked away. You know, everything was fine before I walked away. Then I came back and it was down. Well, the thing is, it was going to be down just a few seconds later, about half a minute I think that took us. We know that serial 1 is up, line protocol is down, means everything is fine physically, but there's a logical issue. And as we saw previously in this section, a PTP link in a lab is going to have a DTE on one end and a DCE on the other. And the deal is the DCE has to supply clock rate to the DTE. And this is a great little hidden command I'm about to show you, and do not freak when you see how much output there is with this, because 99% of it we don't need, and only Cisco's tech support can even tell us what it means. So let's jump in here with show controller serial. And this command, it may work differently for you on a different iOS, but this command has a little bit of a quirk. If you put a space, there we go, we got it between serial and 1, so this iOS is doing it. Sometimes when you don't leave a space here between serial and 1 for show controller, it's going to tell you it's a bad command. We'll see what router 1 does in a second. Now, as you can see, there's an awful lot of information here that to the naked eye and even to the clothed eye really doesn't make a lot of sense. But we don't need any of this stuff down here. This is not what we're interested in. What we're interested in is right there. That tells us that this end of the cable, the DCE end, is connected to this router, router 3. We know that this is the end that has to supply the clock rate. This stops you from having to go in your lab or something and say, okay, let me go through all these cables and see if I can figure it out. Because the DTE DCE cable, it's going to be labeled or actually stamped into the connector DTE or DCE. But this is a really handy command to know that you can use to see that same information. Let's try the show controller. Yeah, that one did it. That's really odd. It's just a little quirk I've noticed over the years. So just put a little space there, no problem. And we can see that R1 is the DTE cable. If we saw DCE here too, we know we've really got a miscabled pod. But the DCE end has to supply the clock rate to the DTE end. Now let me show you another little thing here. Interface serial 1, and I know I'm on the DTE. You're going to get a message from the router, obviously, that says this command applies only to DCE interfaces. I doubt very seriously the exam is going to be so kind. So if I were you, I'd kind of have that memorized, and that show controller command is a good one to know, obviously. It doesn't matter. Whoops. Is this one where I have to do it in 2 words? Okay, works for me. It doesn't matter which one of these you pick, really. I just go with 56,000 or 64,000. And let's see what happens. And your line protocol comes up very quickly. It's scrolled off a little bit. I like to use a larger font because we don't have many messages that long. So it's serial 0, and that's beautiful. And what we'll do is come back in a minute or two and check it and make sure it stays up, as we always do with our DC. With any time you get the line protocol to come up, always stick around and check it again. And we ran show interface serial. We saw the default is HDLC. You saw where to see that. So right now we should be able to send pings across that line. And we'll go back to our equipment. Everything looks like it's still good. And there we go. And just to be sure, this is a really good habit to get into, because I know that one's going to be able to ping 3 in that situation, but as your labs get more and more complex, you have to remember that just because A can ping B, it doesn't mean B can ping A. And of course, in a more complex lab, there's a bigger chance of that happening, but it is an excellent habit for you to get into, just to check it from the very beginning. Even when you know a ping is going to go across, it takes 5 seconds to check it. So by golly, you should check it. So right now, everything is just fine. Now, the endpoints of a PTP link must agree on the encapsulation type. If one end is running HDLC, the other end of the point-to-point link has to be running HDLC as well for its encapsulation, or the line protocol is going to go down. So we've already seen 2 things that can make the line protocol come down: a missing clock rate on the DCE and a mismatched protocol type. We're going to see that in just a moment. Now, again, you're going to have your physical connectivity. That's no problem. We're going to go right back to the routers right now, and I'm going to cause a mismatch because we're going to start with PPP here. And let's go up to router 3 and look at our choices for encapsulation. Now we've got a couple here we do not need to concern ourselves with at this point. ATM DXI, you don't have to be concerned with. LAPB, SMIDS, SMDS, and X25. The three that we're really hammering in this section that are very important to your studies: frame relay, HDLC, and PPP. Really, you've seen everything with HDLC there is to see. We have talked about the little bit of things going on with the type field, and we also know it has to match. If you're using HDLC on one end, you got to use it on the other. But we're going to talk about some shortcomings with HDLC in a moment, because you're generally going to be running PPP over your point-to-point links. Frame relay, we're going to do a lot of lab work with that later, and that's more for multi-point. That's not really a point-to-point protocol. Right now we're going to pick PPP, and we have no choices, so we'll take that. And you can see almost immediately the line protocol is going to crash on you, because we're running PPP on one side of the connection and we're running HDLC on the other. Let's talk right now for a moment about some PPP features and why, even though HDLC is the default encapsulation, you're probably going to change that over to PPP. Well, PPP just offers a lot of features that HDLC does not. And a couple of those features, and this is just a couple of them: authentication through the use of the password authentication protocol, PAP, and the challenge handshake authentication protocol, CHAP. We also have support for error detection and error recovery features, and there is multi-protocol support. Now, we mentioned this, Cisco's HDLC does offer that, but the original HDLC does not, so it's a big plus there. Now, we can authenticate over PPP with either PAP or CHAP, and just looking at the names, maybe that challenge handshake is a little better authentication than PAP, but you also know that anytime we have two choices for the same task, you know you're going to see that on your exams. You know you're going to see the comparisons, and we got to know them inside and out. So we're going to discuss both of them while seeing them both in action on the live routers. And the first thing we'll do when we come back is have PPP running over the link on both ends, make sure the line protocol comes up, and then we'll discuss CHAP and PAP just a bit, and then configure them both and debug them both on the live equipment. We'll do that on the very next video. See you there.